Alright, what's up logic fans? Welcome to our second video on section 3.8. This is video 3.8b, and we are continuing our discussion of indirect proof. Let's get right into it with another example. I'm going to give you a little less build through this time, but we're still going to go through it together. But let me just sort of straight up ask you, you're going to use indirect proof on this one. Again, you don't have to solve this particular problem. In fact, anything that can be done with IP can be done without. We're not going to prove that, but for the sake of practicing the technique, can you go ahead and try to solve this problem using IP? Try it now, pause now, and give it a shot, and we'll come back and do it together. Alright, hopefully you've had a chance to pause and work this through on your own, but since we're using IP, we're going to assume the negation of the conclusion, which in this case is this, and we're going to write a sump, and then we're going to be looking for a contradiction. Same pattern every time, okay? I'm not changing that on you, no tricks, okay? So now what you're trying to do is you're trying to combine this with 1 and 2 in any way you can in order to yield a contradiction, and any contradiction can do. It'll be F and not F, it'll be G and not G, H and not H, anything of that nature will work, okay? So, pause at any point here and try to work this through on your own, but I'm going to walk us through it together here. So, there's different things that can be done here. It's kind of interesting. One thing that stands out to me in particular, just looking at this, and you can think about using hypothetical syllogism on 1 and 2, because they have not F in common. So again, I'm just sort of looking at what do they have in common, what rules can I use. But what's really kind of interesting here is that I've got this not G, and the not G appears here, which is sort of tipping me off to try to use, to try to build this whole construction here, which isn't too hard. I can do not G or H, and that's add on 3. And now look how close this is to this thing. It needs to be cleaned up a little bit, right? So we're just going to do H or not G. And now I've got this construction perfectly right here. And again, there were other ways you could have gone here. This is one perfectly fine way. And what's nice about that is that now I can combine 2 and 5. So after all this setup, what's the big payoff for combining 2 and 5? All right, the big setup is not F, which is yielded by modus ponens on 2 and 5. Okay, and now I'm sort of looking for this contradiction. I'm not really sure how I'm going to get it yet, but I do notice that just sort of looking at my premises here, or sorry, at my rationales, I haven't used my first premise. So it's like, oh, okay, maybe I should try to bring my first premise to bear now. And conveniently enough, I've got something in common. Is there a rule I have that allows me to exploit the commonality between this newest thing I have and the as yet unused premise 1? Absolutely, and I can get G by modus ponens on 1 and 6. Okay, so that's the sort of thought process. I'm just trying to get new things and trying to slowly build to the thing I want, which in this case is a contradiction. So contradiction is pretty easy to get now. Okay, I'm going to use this one, which is just conj, and I'm just reviewing what I have. Okay, so that's conj on 7 and 3. And now, having obtained what I wanted from this assumption, what do I do with this assumption? Okay, I discharge it. Same routine every time. Nothing is changing on you there. Okay, it's the exact same thing. So we're going to do the thing I assumed, arrow, the last thing I got, which in this case is in terms of G itself, which is just fine. Okay, any contradiction of this form will work. So it'll be like that. And then what we're going to do is we're going to justify that by writing IP, in this case 3 through 8. So 3 through 8. Okay. And now we're going to do our typical pattern. And you tell me what's the pattern from here. IP followed by what, followed by what, followed by what if necessary. Okay. So it's going to be LNC, modus tollens on 9 and 10, and if necessary, and it is going to be necessary in this case, double negation on 11. Okay, so see if you can fill these in for yourself, all right? But I'm going to put them up there on the board right now. So what we're going to do is we're going to do LNC, not the case that G and not G, all right? If this is true, then a contradiction is true. Contradiction isn't true, so it's not the case that this thing was true, all right? And therefore, G is true by double negation. Okay, so that's QED, and once again, it follows this pattern every time. All right, every time. So, all right, let's look at another one. I want to give you one where the conclusion isn't just a simple letter, but something a little more sophisticated, so you can see an example like that. All right, so let's see here. Let's take a look at this example. And in this particular case, once again, you don't have to use indirect proof, but we're going to illustrate the method. I want you to think carefully about how you would use indirect proof here. So we know that we're assuming the negation of the conclusion. Okay. In this case, what's the negation of the conclusion? Pause now. Okay, well, the negation of the conclusion is actually just going to be this, right? And so you could think of it this way, and that's fine. But I'm going to ask you to make your assumption look like that. So in this particular case, pause now and try to solve this problem, making this your assumption and then looking for a contradiction. Then we'll come back and do it together. Okay, so hopefully you were able to get to this point. Okay, so you got your premises as usual, and you're assuming the negation of the conclusion that you want, and you're looking for a contradiction. No big deal. I suppose the most natural thing to do right away is just to clean this up using double negation on 3. And then, one thing I always do, just standard operating procedure, right? We've done it before. We're going to keep doing it, is whenever I get a conjunction, I like to com and simp it apart. So we're going to com it, and then we're going to simp the thing apart, right? So we're going to get A, and that's going to be simp on 4. And then we're going to do B, which is simp on 5. So we've commed and simped this conjunction apart, which is really nice. So we've got these two things ready to go. Now, right now, I don't know if I'm going to need these or not, or both of them, okay? I just know that I'm looking for a contradiction, and I'm trying to get some stuff. And I've got these things available if I need them. Later, if I ever want to go back through a proof and do it a more efficient way, I'll write that up. But right now, I'm just sort of doing this just sort of as a reaction to having a conjunction. And looking back up at my premises, which I haven't used yet, okay, which is another tip. I haven't used my premises, right? The 3, 4, 4, 5, nothing about 1 and 2. So I want to try to bring them to bear, and I can absolutely bring them to bear, right? It's not hard at all to see how. It's going to be modus ponens. So modus ponens on 6 and 1, right, is going to yield this, right? And modus ponens on 7 and 2 is going to yield this. Okay, so this is modus ponens on 7 and 2. And it's really not too hard to see how you're going to get your contradiction from this, okay? But one thing you can try to do is you can just sort of try to, you could do it in 2 steps. It's no big deal, but if you modus ponens 7 and 8, you're going to get C. So that's modus ponens on 7 and 8. And then if you modus ponens 9 and 10, you're going to get not B. And now I've got an explicit contradiction. If you found a faster way to get it, that's absolutely fine. So that was modus ponens on 9 and 10. Okay. And now I'm ready to build my contradiction, right? Because I've got B here and I've got not B here. So B and not B. Conjunction on, what was that? That was 7 and 11. Okay. And now the big payoff, all right? Having obtained a contradiction, which is what I was looking for with respect to this assumption, what do I do with this assumption? I discharge it. So what gets written on line 13 needs B. What does the syntax require you to write down here? It requires you to write down the first thing you assumed, which is this, arrow, the last thing you got, which in this case is this guy. So how do you justify it? What goes here? IP, right, 3 through 12. Okay, so indirect proof 3 through 12. And then how do we follow up? So this is our rationale, this is our assumption line, and this is a normal line like here. Okay, how do we follow up all IPs? Well, they're always going to be LNC, modus tollens, in this case it's going to be 13 and 14, and if necessary a double negation, and it's definitely going to be necessary in this case, so double negation on 15. That must be, so this is going to be 14, this is going to be 15, and this is going to be 16. All right, so see if you can finish these off for yourself, but basically we're going to use the law of non-contradiction to set up it's not the case that B and not B. All right, and then after that what we're going to do is we're going to do our modus tollens on 14 and 13 here, which is going to set up this really nasty looking thing, which is just this. Okay, so this is the MIT technical point. This is the correct application of modus tollens to 13 and 14. This line here, which we can then clean up to yield it's not the case that A and B. All right, and that's QED. And the big point that I wanted to make about this was that, let me show you here. When you have certain kinds of, so the original problem was like this, when you have a problem like this, and the conclusion is not just a single letter like A or B or C by itself, but it's something more complex. You're taking the negation of the whole thing, however complex it is. If that's what you're doing, if you're going to use indirect proof, that's how you proceed. Okay, so I wanted to make that point for you. Okay, on the next video, 3.8c, what I'm going to do is I'm going to show you how to use indirect proof to establish theorems. We're going to go through an example like that because there are a couple of those examples in the textbook. So, catch you on 3.8c.